Hi, welcome to Sachin Study Tech. Today topic is recursive algorithm. So what is the recursive algorithm? An algorithm is said to be recursive if the same algorithm is invoked in the body. So this is the recursive algorithm. So in that recursive there are basically two types is there. One is the direct recursive and another one is indirect recursive. So here the direct recursive, an algorithm A is said to be direct recursive if it calls itself. Okay. Now indirect recursive, a algorithm A is said to be indirect recursive if it calls another algorithm which in turn call A. So what is the meaning of that? So you can see now you can see the, for example, here it is A, this is one algorithm. This algorithm will call the same algorithm A. So you can see this is called the direct recursive. A algorithm calls itself. Okay. So A algorithm calls itself. You can see here. So now we can see the same algorithm calls itself is called the direct recursive. So indirect recursive means, for example, A algorithm calls B algorithm. For example, A algorithm calls B algorithm and B algorithm calls B algorithm. For example, this is the algorithm, B algorithm calls A. So this is called as a indirect recursive. So here A calls B and B calls A. So indirectly A calls A. So this is the indirect recursive. Now every recursive algorithm consists of two key parts. One is the base case, that is the stopping condition, and then one is general case, that is recursive step. So what is the base case? Stopping condition. Okay. So this is the simplest possible scenario where the function does not call itself. Okay, cannot call the same function itself. That is called as a stopping condition. That is the base condition. Okay. Now general case is, this is where the function calls itself with the smaller or simpler input. It gradually breaks down the problem until it reaches the base case. So this is called as a general case. Now we can see the example. So algorithm to find factorial of number n. So this is the algorithm factorial of n, and if n equal to 0, return 1, else return n into factorial of n minus 1. So what is the base case? So this is the base case. You can see here factorial of 0 equal to 1. This is the base case. Okay, general case, that is the stopping condition. You can need not to iterate, you cannot call it. So general case means the factorial of n equal to n into factorial of n minus 1. This is the general case. Now we can see, for example, n value is 4. For example, you can pass n value is 4 here. N value is 4. So generally any recursive algorithms, recursive functions, it can use the stack. So what is the stack? Stack follows last in first out. Stack follows last in first out. There are basic two operations is there. One is the push and pop. Push means you can insert the element into the stack. That is the push. If you want to pop, you can perform the pop operation from the stack. That is the removing from the stack. Okay, top of the element you can remove it. So that is the pop operation. Now we can see generally in recursive it can use the stack. So here it is the stack. This is the stack. I am consider. Now we can see the n value is 4. So here factorial of 4 equal to 0, the condition fail. So else statement is executed. Now else statement is n into factorial of n minus 1. What is the n? N value is 4. Now 4, n value is 4. Okay, in factorial I can write here f incomplete without putting the complete name here. Just factorial f is used. So n minus 1, that is 4 minus 1, that is fact of 3. So again you can call the fact of 3 function, factorial of 3. Now 3 equal to 0, so condition is fail, then this statement else statement is executed, that is 3 into factorial of n minus 1. So 3 into factorial of n minus 1. So here the 3 and 3 into factorial of n minus 1, that is fact of 3 minus 1, that is 2. Now you can see here also fact of 2, again you can call this function, and 2 equal to 0, condition fail, this else statement is executed, that is 2 into factorial of n minus 1. So here you can see 2 into factorial of n minus 1, that is 2 minus 1, that is the factorial of 1. So again 1 equal to 0, return 1, but it is condition is fail, then else statement is executed. So here the fact of 1 minus 1. So here the factorial n value is 1 and fact of n minus 1, that is fact of 1 minus 1, that is 0. So here it can see the base case, factorial of 0 returns 1. So here it can see 0 equal to 0, so return 1. So the fact of 0 value is 1. So 1 into 1, that is 1. And fact of 1 value can pass here, the fact of 1. So fact of 1 value is 1. 1 into 2, that is the value is 2. Now fact of 2 value is 2. You can pass here the fact of 2. So value is 2. So 2 into 3, that is 6. So fact of 3 value is 6. Now 6 into 4, that is 24. You know the 4 factorial. The 4 factorial value is 24. So this is the example how we can executed this factorial of recursive function. Now we can see the algorithm for generate nth term in the Fibonacci series. So here fib of n, if n equal to 0 or n equal to 1, return n, else return fib of n minus 1 plus fib of n minus 2. So here also, for example, I am consider n value is 4. N value is 4. Now we can see fib of 4. So fib of 4. So here the n equal to 0 or n equal to 1. So n value is 4. 4 equal to 0 or 4 equal to 1. So both the conditions are fail. Then else statement is executed. Fib of n minus 1, that is fib of n minus 2. Now we can see fib of n minus 1. Fib of n minus 1 is 4 minus 1, that is fib of 3. And fib of n minus 2, that is fib of 4 minus 2, that is 2. F of 2. Okay, fib of 2. So now again here the same condition, fib of, you can call this same function here, n 3 equal to 0 or 3 equal to 1, here the condition is fail, then else statement is executed, fib of n minus 1 and fib of n minus 2. So here also you can divide here the fib of n minus 1, that is fib of 2, and here fib of n minus 2, that is fib of 1. Now again we can see fib of 2, 2 equal to 0 or 2 equal to 1, condition fail, then else statement is executed, fib of n minus 1 and fib of n minus 2. Now we can see fib of n minus 1 value is fib of 1. So here the fib of 1 and fib of n minus 2, that is 2 minus 2, that is fib of 0. So you can see n equal to 0 or n equal to 1, so fib of 1. So fib of 1 means n equal to 1. So either any one of the condition is true, then it can return n value. So for example here the n value is 1. So n value is 1. This condition is true. Now we can return 1. So f of 1 value is, now we can see f of 1 value is, it can return 1. So here also you can see f of 0. So n equal to 0. So return 0. So here it can return 0. You can see in else statement fib of n minus 1 plus fib of n minus 2. So you can add it 1 plus 0, that is f of 2 is 1. Here also f of 1. So f of 1, you can see that f of 1. So here also you can return the value f of 1. So 1 equal to 1, return 1. So n value is here also 1. So 1 plus 1, the f of 3 value is, now f of 3 value is 2. And here also the same thing you can expand. So you can see here also f of n minus 1, that is f of 1, and f of n minus 2, that is f of 0. You know already f of 1 value is 1, f of 1 value is 1, f of 0 value is 0. So 1 plus 0, that is f of 2 value is 1. You know 2 plus 1, that value is 3. So fib of 4, the value is 3. So what is the Fibonacci series? You can see here, for example, here it is a 0 index 0, and here 1 index 2, like that. Here it is 3 index, third index, here third index, and fourth index 4 and index 5, like that, index 6. For example, here the initial value is 0, here the value is 1. So you can add the previous value. 1 plus 0 is 1, and 1 plus 1 is 2, the value is 2. Next 2 plus 1 is 3. So you can see fib of 4, the value is 3. So fib of 4, the value is 3. This is the value. Next, if you find out the fib of 5, 3 plus 2, that is the 5. Okay. If you want to find out fib of 6, that is 5 plus 3 is 8, like that, and so on. You can find the Fibonacci nth number. Okay. Now you can see the same what are the factorial, recursive factorial, and Fibonacci series you can implement it in, for example, in C long ways. You can see here the factorial. Okay. So this is the main function, int number, enter the number, and you can read that number. That number will be stored in n variable. Okay. If n number less than 0, that means it is any negative number. So factorial is not defined for the negative number. If any positive number, you can enter any positive number, then you can call the factorial function. So factorial function already we are discussed. Okay, factorial of, for example, factorial of 4 and 4 equal to 0, return 1. If the condition is failed, then else state, return state, this statement is executed, return n into factorial of n minus 1. Already we are discussed. So this is the base case, this is the recursive case. So you can see the output here. You can see the output. So n value is, for example, I am enter n value is 4. So what is the output here? The factorial of 4 is 24. So this is the output. Now you can see the Fibonacci series here also. Int main. So number I am consider, enter the number, and you can read that number. If number less than 0, that is the negative number. Fibonacci sequence is not defined for negative number. Else, if you can pass any, you can enter any positive value, then you can find, you can call this Fibonacci function. Okay. So here you can see Fibonacci int n equal to 0 or n equal to 1, return n. Okay. Otherwise return Fibonacci n minus 1 plus Fibonacci n minus 2. This is the recursive case. So n equal to 0, n equal to 1, return n. This is the base case. Now you can see the output here. For example, n value is, for example, 8. So what is the value? Okay. So 8th Fibonacci number is 21. So already you know the 5th Fibonacci number already we are discussed here. What is the 5th one? 5th one is, okay, 5. 6th one is 8. For example, I am consider, you can enter the value is, the enter value is, for example, 6. So what is the value? So 6th Fibonacci number is 8. So this is the output. The same thing you can implement it. What are the program I are discussed here? The same implemented in Python also. So this is the Python code. So if you know already number, so this is the one variable. So this is the input function here. What are the value is returned by default, it is a string type. So that's why I am using the conversion, that is the integer type conversion. Okay. For example, enter a number. If number is 4, for example, if number 4 less than 0, that is factorial is not defined for negative number, it can return the same thing. Else, if can enter the positive value, any positive value, then you can call this function. Okay, factorial of that number, you can call that function. For example, n value is 4, 4 equal to 0, return 1, otherwise return n into factorial of n minus 1 already are discussed. So here it is a recursive case, this is called as a base case. Now you can see the output. Here also you can see the output. Here enter a n number. For example, number is 5, so the factorial of 5 is 120. Now the same here also you can Fibonacci number. So here also you can read one number, and if that number is not negative, then else statement is executed. So Fibonacci of that number. So you can call this function, and n equal to 0 or n equal to 1. So return n, already you know that. So this is the base case. Okay, otherwise return Fibonacci n minus 1 plus Fibonacci n minus 2. This is the recursive case. So what is the output here? You can see. So for example, enter the term number. For example, the number is 5. So fifth Fibonacci number is 5. For example, number is, for example, if you want to find out fib of 8, so the number is 21. So this is the example. The same thing, what are the Fibonacci number or factorial is explained in the algorithm. The same thing you can implement it in two languages, that is one is the C language, another one is Python programming language. Thank you for watching.